Wait a sec, guys. Wait a second. Uh, s- let's go. Hello, guys. So we are gonna see today is this offensive security intro. Hack your first website legally in a safe environment and experience an ethical hacker's job. Let's see how it is. What is offensive security? To outsmart a hacker, you need to think like one. This is the core of offensive security. It involves breaking into computer system, exploiting software bugs, and finding loopholes in applications to gain unauthorized access. The goal is to understand hackers' tactic and enhance our system defense. Beginning your learning journey. In this TryHackMe room, you will be guided through hacking your first website in a legal and safe environment. The goal is to show you how ethical hacker operates. Our lab can also be reverted to their initiated state. So don't be afraid to break the machine. Experiment as much as you like. We got you covered. Let's go, guys. Which of the following option is better present the process where you simulate hacker's action to find vulnerability in a system that is offensive? The sack, isn't that correct? Yes, that is correct. Starting the lab. Oh, what the hell? What the sack? Well, that is opening in there. Let's go. Here at TryHackMe, we use virtual machine to create simulated environment that serve as practical complements to room. In this room, we have prepared a fake bank application called Fake Bank that you can safely hack. The virtual machine with the application should start automatically for you if it doesn't click on the smart machine button below. Alright, start machine, smart machine. Uh, your screen should be split in half, showing this content on the left and only newly launched machine on the right. If you hide it later, you can always click to show split view button at the top of the display to show it again. Alright. This some bank thing. Let's go. Uh, can't see the virtual machine. Click here. What the hell? Alright. What is the bank account number in the fake bank web application? What is the question? What is the bank account number in the fake bank account application? Uh, why is it so damn big? Uh, uh, banking account 8881 triple eight one triple eight one. Let's go. Your first hack. Briefing. Our goal is to find a way to hack the fake bank application to steal money. For that purpose, they have provided us with an account in the bank just as we just as if we were a regular user. One of the easiest ways we can try to hack the application is by finding hidden features in the application. Sometimes application will expose sensitive functionality to the users with a secret URLs. If we can't find such URLs, we might be able to perform action that a regular user is not supposed to. But to find the hidden URLs, we will use a tool called DIRP. This tool uses a brute force approach by taking a list of potential page names and testing one by one if they exist in your website. This approach works because people use predictable name a lot of time. Opening the terminal, they are using dir. I use GoBuster, dude. What was their intention to find it? To find hidden URLs, we will use dir. All right, let's go. Uh, Paste. Uh, oh, it gives URL, bank deposit and bank images. We found two. All right. Oh, it chooses automatic keyword list. All right. The output of the command might look a bit intimidating, but here is a simple breakdown of what is reported. The first section of the output tells the URL base we scanned, which is just the URL we gave the tool. It also shows the location of the wordlist file used by the tool, which contains common page names that will be tested during the brute force attack. In this case, the tool uses the default word list included with the tool located at user share dirp word list common txt. There is a copy of common txt file in your desktop as well if you want to explore it. The lines starting with the plus sign are the result of the scan. In this case, the dir was able to find two URLs for you. Try opening them in the machine browser. You might find something interesting. dir should have found two hidden URLs. One of them is what is the other one? All right, that is images, right? Which one is they asking? It is very long. Might this be? Copy, and there it is. Wait a sec. They are telling us to go to this URL, right? See what is in there. Admin portal. We are in the admin portal. We can use the account number and amount to deposit in USD. The hell, that easy. Mm, you should have found a secret page that allows you to add funds to the bank account. Type a hidden page into the fake bank website using the browser's address bar. In this page, you should be able to fund your bank account. Remember, your bank account number is 881. Let's add 2000 to it. If you manage to add 2000 or more to your account, you should be able to see a new balance reflected on your account page. Press the return to your account button at the end of the deposit receipt to go there and now confirm that you got the money. Let's see, we will add 2000, deposit the money. Uh, this one we will refresh. Yeah, bank hacked. That was very easy, but right. We will add a bit more. We will add $1 million. Wait a sec. Uh, yes. We will add. How much is that? I don't know. Let's go. Deposit. Who is this Elon Musk? Who is this? Who is this Elon Musk? Bring it on. Well, whatever. That was very easy, if you. What the hell? Wait a sec, guys. I forgot to. This one. Bank app. Copy. Paste. If your balance is now positive, pop-up should appear with some green words in it. Input the green words to the answer, all in uppercase. Make sure your new balance is positive numbers. Okay, fuck. Is that gone? I got that from here. Right. That room is completed. Very easy room. Stop the recording. Start the recording. Let's go, guys. Today we are gonna go with that module computer software basics, and today we are gonna learn data encoding. Learn how computer encodes character as from ASCII to Unicode UTF. Introduction. In the previous room, you learned how numbers are represented in the computer as binary digits. Binary digits bits and how these bits can be grouped into hexadecimal digits. We also explored how to express colors using numbers. Now, if everything is stored as number, how do we convert them to letters, punctuation and emojis? In this room, you will learn that characters are just numbers with the agreed meaning. That agreement is called an encoding. Have you ever opened a document, visited web, visited a web page, or downloaded movie subtitle files only to see the file appear as weird gibberish? One reason for that is the user who saved the file and user who opened it are using different encoding. Representation is the idea that data lives as bit and numbers in memory. At the same time, encoding is a specific agreed upon mapping between numbers and meaning, such as which number corresponds to the character A in text. Each character each character like Q5 or what is that apostrophe mark something like that is assigned a numeric code. So a string becomes a consequence of numbers that the computer stores and moves around just like any other data. Learning objective. Upon completion of this room, you will learn about ASCII, Unicode, UTF-8, UTF-16, UTF-32, how emojis is encoded, and how what causes weird gibberish character. Prerequisite is, let's see, data representation. We learned this in the previous room, right? Yes, we learned this. This video will be uploaded soon, I guess. Let's go. ASCII. We already learned that the digital computers only understand zeros and ones. Starting from 0 and 1, how can we save and display text? For example, how can we save the text TryHackMe in a file? What will such a file contain? To be able to answer this, we need to agree on what bit represents T, what bit represents R, what bit represents Y. Oh, this is TryHackMe, and so on. Let's say that we all agree to represent T with the following stream of bits 0 1 0 1 0 1 1 1 0 0. Then all computer systems should store T the same way, and the letter when computer encounters it will recognize it as C, as T. Of course, we need to do this for all letters in the alphabet, digits and special characters. This approach requires a standard that the computer manufacturer designer and the programmer agrees to adhere to. One of the earliest standard of English letter was ASCII. ASCII stands for American Standard Code for Information Interchange, and it is an early character encoding from 1963 that uses numbers 0 to 127 to represent English letters, digits, punctuation, and some control characters. Remember that A stands for American, as this will come in handy later. As you might have noticed, the original ASCII was limited to 7 bits. ASCII act as a small polygonal, polygonal dictionary between text and numeric code. Consider the following samples. From the original ASCII table, since the table has 180 entries, we only made a brief section to give you an idea of how things are represented in ASCII. Decimal, hexadecimal, binary, symbol, and description. 48, decimal is 48, hexadecimal is 30, binary is this number, symbol is 0, and description is 0. Same goes for year. Uppercase X, 88, 58. Oh my god. There are several things you can observe. First, the letters are in order. You know the the hexadecimal or decimal number for B. You can figure out the decimal number of A and C and the lowercase letter. For example, A, B, and C are assigned the hexadecimal numbers 61, 62, 63 respectively. Same for the uppercase letter. To A to Z and 0 to 9, when ASCII encoding, a computer system reads 41 in a file and displays A on a screen. When it reads 42, what the hell? A computer. Wait a sec. Uh, there is. Wait a second. Let me read it here. What it reads 42, it displays B and so on. Secondly, each character has its own ASCII. For example, wait a sec. Let's go from start. There are several things that you can observe. First, letters are in order. If you know the hexadecimal or decimal number for B, you can figure out the decimal number of A and C and the lowercase letter. For example, A, B, and C are assigned the hexadecimal number 61, 62, and 63 respectively. Same for the lower uppercase letters A to Z and 0 to 9. When asked using ASCII encoding, computer system reads 41 in a file and displays A on screen. When it reads 42 and it displays B and so on. Secondly, each character has its own ASCII. For example, a bracket is represented by the hexadecimal number 5B. Wait a sec. What's up, app setting? How the hell am I supposed to off that? Let's go. Uh, Sorry about that. Let's see. The timer is 20 minutes. All right. Already 20 minutes after recording. 9 minutes. TryHackMe in ASCII. Let's say you open a text file. Why write TryHackMe and save it as text file.txt? How will the file look on the bit level? Let's find out. If you're interested in seeing the storage on disk bit by bit and assuming that it is using ASCII, you will see something similar to the following. Obviously, this is not readable by any human being. These are extract binary represent of all the letters in TryHackMe, followed by a new line. When you open this file, your editor will read these bits and display the following character. And last n is a new line that you get when you enter the key. Because reading binary numbers is cumbersome. What is this? Cumbersome. I don't know what the hell is that. And error prone to us. We prefer to use hexadecimal digit as you remember from the previous room. We go 4 bits into a single hexadecimal digit. Our file looks like this in the hexadecimal. And if you want to look up the decimal representation, it would be as follows. However, it is common to use decimal digits. It is more common to use hexadecimal digit when we want to show the bits. Uncommon to use decimal bits, alright. You can use the attached static site yourself to experiment more. European language. ASCII provided a way to encode the English alphabet. However, you need an encoding to support other European languages such as Spanish, German, Polish, Czech, and Romanian. To name a few, ASCII uses 7 bits. To name a few, ASCII uses 7 bits, and with an 8th bit, we get 128 more characters to cover. However, the reality is more challenging. The additional 28 letters are not enough to cover all the letters of European language. The IEC 8859 series international standard created several standards. Each standard covered a set of language. ISO 8859 Latin 1 covered a Western Europe languages like German, French, Spanish, Italian, Portuguese, Catalan, and Nordic languages. Example, Irelandic. What the hell is that? And Latin 2 supported Central West Eastern European languages like Polish, Czech, Hungarian, Croatian, Romanian, and Slovak. In other words, if your document is saved using this and the letter later read and displayed as it was saved using ISO 8859-2, non-English letters are likely to be displayed differently. Wow, that was interesting. This is how A used. Let's see. Oh, zero. Zero. We cannot type only one word, all right. ASCII, that is very good, very good, very good. Let's go with that. Uh, what is the ASCII code for decimal for the character? It is 64. What is the character that has ASCII code of 35? Let's see. One is 61, all right. It is a number. A, that is way off. A, Is that it? This is not that. It is one. No. What is the correct that has a ASCII code of 35? Uh, 30, 35. Let's see. We cannot use that. Wow. Uh, which is easier is let's see, 2, let's see, 3 is 5. 30 might be 5. I don't know. Oh, it is not. So here we can change it. Oh, we can change it. Oh my God, I am just. Oh, we can do that. Wait, was it? It was way off. I don't know. What is the name of the character that has a ASCII code of 7? Uh, well, it is kind of hard. Practice it. Even I don't know more about that. Let's go. Let's continue the room. Uh, we learn that ASCII is a 7-bit standard that defines 28 characters covering English letters, digits, and basic punctuation. We also noticed how ASCII, with its 7 bits, didn't have room for characters such as using 8 bits extended. ASCII tried punching this with a regional variants. ISO 8851, ISO 8859 too. Windows 1252 among many others, but this caused chaos. For example, if the sender writes and save using ISO 591 Latin 1, Latin, we will use the Latin. The encoding, the recipient opens encoding, Latin 1 encoding, and the recipient opens and reads the document using Latin 2 coding, encoding. They will see R, and it is clear how opening a document requires us to use the same encoding used when saving it. Otherwise, various characters will not be displayed correctly, or even more confusingly, they might be incorrectly replaced. Unlike English, which has 26 letters and needs 52 characters to cover uppercase and lowercase, Arabic needs more than 250 characters to cover its various literature and diacritics. Moreover, the number escalate rapidly when considering Japanese and Chinese. In Japanese, 2000, 2136 kanji logographical characters are considered daily use character as mandated by Japan's Ministry of Education. In fact, the GIS 028 standard defines 6879 characters in Chinese. Educated native recognize around 8,000 characters. Furthermore, the GB 18030 defines more than 88,000 88 87 87,88 87,8807. I don't know if I am reading correctly. I am full. And still, we have not considered encoding emoticons, emoji. Oh my god. In other words, it is essential for both the sender and recipient to use the same encoding. Moreover, we need to encoding that can include all the characters from all the languages. This situation brings us to Unicode. Unicode is a universal character encoding standard. It assigns Unicode points to character from all modern and historical writing systems worldwide. Unicode support a interchange processing and display of text in diverse language. In other words, we don't need to worry about picking a specific encoding standard that is compatible with the language we are using. Furthermore, this makes it easy to use different language in a single file or a message. And most importantly, because this is a standard that fits all, we don't need to worry about encoding used by the original author, as they also be using Unicode. Unicode is a character set standard that assigns a unique number to every character across all languages. Example, U plus 001 Latin A, U plus 03A9 Greek, 0 plus 03042 Japanese Hiragana. Unicode 7.0 is currently the latest version of the Unicode standard. It defines the close to 157,000 characters, almost 4,000 of them are emoji sequence. Wow, beautiful. UTF-8, UTF-16 and UTF-32. Uh, because you will encounter UTF, UTF-16, UTF-32, we will briefly cover them without going to too much depth. What you need to know is that UTF-8 is very common on the modern web. It encodes Unicode points into 1 to 4 bytes dynamically. In other words, it decides on the number of bytes based on the character complexity. ASCII character U plus 00000 to U plus 007F use exactly 1 byte, ident- identical to the original ASCII, assuring seamless backward compatibility. Non-ASCII cas- non-ASCII characters like what the hell is that? U plus 03A9 use 2 bytes, while complex scripts or emojis like fire requires 4 bytes. This flexibility allows us to cover the Unicode standards without wasting bytes. UTF-16 takes a different path. It uses either 2 or 4 bytes per character. Common characters like most Latin, Cyrillic or Chinese Anzi fit in 2 bytes. However, rare ones like emoji or ancient script require a pair. Two 16-bit units totaling 4 bytes. For example, a letter A is encoded as U plus 0041, while the emoji needs 2 and is encoded as U plus D83D plus U plus DD25. Finally, UTF-32 is the simplest but also most wasteful. Most wasteful. Every Unicode point uses exactly 4 bytes. For example, A is encoded as extra zeros and 0 is encoded and they add extra zeros. Let's look at a few more examples. One of the Chinese letters that appear on the offensive Linux distribution, such as Kali, is which means dragon. In Unicode, it is this or this, depending on whether it is UTF-16 or 32. This smiley face is nothing more than this in UTF-32. For a computer, that's likely this one. Uh, this The Japanese letter tsu, which some people use as a smiley face in some region outside Japan, it has a code this one or this one depending on whether it is UTF-16 or 32. Arabic letter ta, and some people use it as a smiley outside the Arab world. It looks close enough to smiley face from a Unicode's perspective. That is this one. And the Unicode, the Black Knight in the chess uses the Unicode. This one, in other words, the computer reads and shows the Black Knights thanks to Unicode. We created a static site to help you look characters and explore one available most. This is called. What is the uh what the hell is that emoji? I never saw that. Uh, Let me do this. Copy. Very easy. Very easy method, guys. You can always do this. Uh, this one, copy, paste. What is UTF-16 of encoding? What is it? Is stu, right? They said it is something like stu. It is a Japanese character, stu. What are they asking? Unicode 16. Copy and paste. What the hell? What is the UTF-16 encoding of stu? Note that stu and stu are two different characters. Yeah. We use this. We need this. Sorry about that. See. Always read the question, guys. Always read the question properly. Let's see. What is the character that has a following UTF-32 encoding? Let's see. Wow, that is a emoji. What is the character that has a following? Oh, this one. Let's see. Control C. It's a knight. Let's go, guys. Let's go. In this room, we learned about ASCII and its limitation, and about unique and three encoding standards: UTF-8, UTF-16, UTF-32. We explored how Unicode enables to use cover not only the world's language but also symbols such as chess pieces and emojis. If you are curious to see how computers manipulate data, join the Python demo too. We are adding to that. Let's go. Hmm. uh, let's go, guys. Guys, we are gonna continue it. Software basic module. Today we are gonna learn Python simple demo. It's a premium room, so you need a subscription. Explore what a basic Python program looks like. Introduction. In the first room, data representation and data encoding, we learned how computer understand numbers, characters, colors, and emojis. In this room, we will explore one of the most popular and friendly programming language, Python. You must have heard of Python programming language numerous times. Python is high level general purpose programming language. By high level, we mean it hides most implementation details. General purpose means you can use Python for a wide variety of scenarios, from web application and automation, script to data science and machine learning. In this room, we will create a guess the number game. Our plan will be as follows. The computer secretly picks a number between 1 to 20. The user keep guessing until they get it right. The computer tells the user whether their guess is low or too high. Example session running the program is shown below. Python guess the number.py. I am thinking of number 1. Take a guess. 10. Too high. Try again. Too low. Try again. Learning objective. Learn about both the Python variable. Understand conf- how conditional statements are used. See iterations loop in action. Iteri- iteration iteration loop. All right, sorry about that. We have completed this. Let's see. You can follow along by starting the attached VM by clicking Start Machine button shown above. The Visual Studio Code should open automatically as shown in the screenshot below. The program needs to start by picking the random secret number between 1 to 20. Then the user will begin making a after guess after another till they get it right. This approach requires two variables, secret and guess. We can also track the number of tries attempts it, it took the user to find the number. For this, we will use the variable tries. Python offer a random renit method which returns a random integer within the special bounds. For example, random ran, random randint 1 to 20 returns a random number between 1 to 20 since the user has not made any attempts. We set tries to 0. Moreover, we set guess to the value outside the valid range to tell the user that the program picked the number. We use Python print method to display an informational message on the screen. To show the current Python script below, this will be the script. Import random gives us the tools for picking random numbers. Secret a Tries zero guess. Start with the value that cannot be the secret since secret is one. And I am thinking of a number between. Alright. This code Zeppelin archives the following: the use of random rand int method from the random library to pick a random number between 1 to 20 and it save it to secret. Creates two variable tries and guess and set them to 0. Display a message on the screen to inform the user that the number has been picked. With our variable ready, we prompt the user to make a guess and set the guess accordingly. We begin by saving the user's input into a temporary text variable, then use Python's int to convert it to integer. Furthermore, need we need to increment tries each time the user make a guess. Uh, Input take a guess, input returns take a guess a string. Guess int text convert the text into number. Tries plus 1. Okay, they are adding. So far our program does the following. Pick a random number 1 to between and save it to secret. Ask the user to guess and convert it to integer and save it in the guess. Increment tries by 1. To check whether the user made the correct guess, we should be able to compare against the cases. It requires additional statement and the comparison operator. The incomplete graph. In this task, we build the basic program that you test for yourself and edit in the attached VM. Although this program picks a random number and reads the user input in it, does not compare the two, which makes it practically useless as a game. In the next task, we upgraded this program so that it gives users some feedback on how their guess compare to the secret number. The program below is saved as guessVPY in the open library. Let's see. Oh, it is in there. I don't know, man. What is the name of the function we use to display the text on screen? That is print. What is the name of the function that we use to user into convert user into an integer? This is a guess. I don't know. Let's see. I guess it is guess. No, let's see. The number 0 appended bracket to the function name. Remember to append the name of the function that we use to come. Oh. It is int and we need to append bracket. All right. Let's see. Let's run it. Uh, let's go with 15. Huh? That was funny. I am very not good at that. Let's see. Oh, here it is. More here it is. Let's go. Before starting, please note that you can download the attached zip file It includes all the versions of the program that are present on the target VM. This archive allows you to review the project evaluation, compare implementation, or test each version independently on your local machine. Having all the iterations in one package should make your work efficient. Next, we compare the user's guess to the secret number and give a useful hint whether it is out of range, too low, or too high, or if they got it right. It is like asking ourselves, is the number less than 1 or greater than 20? If if the answer is yes, we tell the user the number is out of range. If the answer is no, we suppose a second question. Is the user's guess is less than the secret number? If the answer is yes, we tell the user guess it's too low. Let's rephrase this to ratio code. What the hell is that? Language that is closer to the program language. The same as that. If the guess is less than 1 or greater than 20, print out of range. If this is not the case, proceed to next step. Else, if the guess is less than or secret number, print too low. If this is out of not the case, proceed to the next step. Else, if the guess is larger than the secret number, print to I. If this is not the case, then proceed to next step. Else, print you got it. By reflecting on the above story, it is only logical that if the guess is not less than or larger than the secret number, it would be equal to the secret number. In the programming, however, the condition after the it if is not true, written as if condition in Python. The program checks the condition after the else if, written as elif condition in Python. If it is also false, it checks the next else if there is no more else if the statement left, the program executes the final else written as else in the Python. Let's convert the above pseudocode into working Python. They did this. If guess 1 or guess 20, print the number is out of range, try again. इसके अंदर else if guess the secret, print too low, try again. Guess too high, else. In this implementation, comparing the user's guess to the chosen secret will lead to various cases. The user make a guess outside the allowed bounds 1 to 20. The user guess is less than secret. The user's guess is greater than secret. The user guess is correct. If the above look confusing, consider the following numerical example. Oh my god, I am having a headache. Wait a sec. Uh, so bad. Hello, wait a sec. Hello. Display capture, audio input capture. Audio input capture. Please put right. I guess the sound is coming properly. I don't know, but let's go. Uh, Numerical example. We assume that the secret number is 10. If user input is 30, the first if condition will evacuate to true. The Python will execute the part after. If guess 1 or guess 20, print number is out of range. Or lesser than 1 or guess is greater than 20, print number is out of range. Try again. We assume that the secret number is 10. Suppose that the user 5, inputs 5. The first if condition will evacuate to false because 5 is neither less than 1 or greater than 20. Python will check the condition following first elif and it will evaluate the evaluate true because 5 is indeed less than 10. Consequently, the program will print too low, try again. Third example, we assume that the secret number is 10. Suppose the user inputs is 15. The first if condition will false and because 15 is neither less or greater than 20, the program will check for the condition following the elif and it will also evacuate false because 15 is not less than 10 and the program will check the condition following second elif and this will evacuate true because 15 is larger than 10. As a result, the program will display too high, try again. First draft. In this task, we will build a working program that you can test for yourself and edit it in the VM to main. The main limitation is that this program gives the user one chance in the next task. We upgrade this program to allow the user to infinite the number of tries to make correct guess. The program below is saved as guess Vito Pi in the home Ubuntu Python demo directory. This one is, let's see, import random, use the tools, secret, it is telling the secret is between 1 to 20. This is good. Start with the value that cannot be the secret since the secret is 1 to 20. I am thinking of a number between 1 to 20. It will print on the screen. Text input to take a guess. Input returns text. Uh, when we type something, it will do this. Guess it is a int text. Convert the text into numbers. Tries. It will add. If you try one number, it will add one try. Give the using if and elif and else. If guess 1 to 20, less than 1 or guess is greater than 20, it will print the number is out of range, try again. Uh, Alif, guess the secret. It is, oh my god. Let's see. If it is less than cigarette, if it is true, it will give this, try again. If it is in the range, like if the secret is 10, if the secret is 10, it will go to here. It is true. It is less than cigarette, then too low, try again. And same as this one, but if the input is 11, secret number is 10, if the input is 11, it will show like too high, try again. And if all this is over and then else, yeah, if you get the correct one, you get this. If you put the 10, it will give you this. What does Python write else Alif? As you can see here, Alif. What will the program display if the user's input is 50? User's input is 50, that is the number is out of range, try again. Uh, you can try this here, all right? Here it is, right? Yeah, let's see. Run the program. Press the number, I will add 50. Where the fuck am I? Sorry about that for using inappropriate word. Wait a sec. Let's go 50. The number is out of range, try again. Now it will, it, the first one was false, right? See, let's see. Now this one was false. Uh, this one was true. Sorry about that. This one was true, so it give the answer. Now we will make it this one true. Let's see. 9. Secret number is 10, right? Now we will go with 9. Too high. Too high. Oh, it gets random, right? It is too high. Like it is more than 9. See, we will go with 1. Or too low, try again. It is number between 1 to 9. Let's try it. Let's go with 5. Too high. Now let's go with 3. Oh, answer is 2. There, you got it in 6 tries. The try is it incremented as we gone and it shows here. What a beautiful, what a beautiful. Let's go. It is too hard to guess the number when the given a single chance. To make this game more interesting, it should provide the user with at least a few chances. It will be highly tolerant and allow the user as much attempt as needed to find the secret number. To give the user once, more than one chance, we need to use our secret weapon, loops, in the programming. Loops are more formally iteration allows us to execute the same line of code multiple times in more formal phrasing. We can iterate over the same code block as long as the specific condition holds. Let's look at a few examples of iteration in our daily life. Consider the case where you want to buy a new t-shirt. You will see one shop after another until you find one that suits you. The condition here is finding the suitable t-shirt. Consider another example where you are searching for an empty parking place in a vast parking lot. You will check one row of car after another until you finally find a space. The condition here is finding a suitable parking space. Back to our game, we keep repeating the code we wrote in the task 3 until the user gets matches the secret number. In Python, does not equal is written as this one. In other words, the condition guess does not equal the secret is written as guess not equal secret. To write this as a while loop, you use the while condition. In, in our case, it is while yes is not equal to secret. Let's trace the code from task 3 to task 3 in the body of our while loop. Let's see. They added this. Take a guess. The code above will execute as follows. The first Python will check the condition after the while. If it is true, it will run all the intended lines. If the condition is false, it terminates. We assume that the secret number is 10. In the first run, the guess is 0. The while condition will evacuate the true because 10 is not equal to 0. The program will ask the user take a guess and it will proceed from there. We assume that the secret number is 10. If the user entered 5 earlier, it means they did not guess the number in the previous attempt and while condition is it, uh, while condition will evaluate to the true because 10 is not equal to uh, 10 is not equal to 10. The program will give the user another chance to prompt. What the hell? We assume that the secret number is 10. If the user entered 10 earlier, it means they successfully guessed the number in a previous attempt. Let's see if the program will prompt them to another guess. The while loop will evaluate to the false because 10 is equal to 10. In other words, 10 is not equal to 10 is false. Intended code block within the while statement will no longer execute. The second draft. In this task, we have completed coding our game. You can test it for yourself. Edit on this program is below saved as v3py. What type of loop does this program use? That is while loop, not HIL. Uh, what will the program display if a user makes the characters in 3 tries? Let's see. Uh, da, 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 da. Secret number was uh, there is nothing that is maybe you got it. It is same as this, but there is what the hell? You got it in you got it in 3 tries. Let's do this. Uh, let's go with 5. Too low. Is it 2 again? It is 1. Oh my god, I messed up. I need to go higher. 10 maybe. Too low, maybe 15. You got it in 5 tries. Let's again do it. Let's see. We will go with 10. Too high. 10 is high, then it is 5. Bro, I got 15, bro. Sorry about that. 5 is too high. Maybe 2, I guess. You got it in 4 tries. Let's forget it. You understand that it is very simple, but as we go progress, it will become hard. I am very bad at programming. In this room, we cover three key pillars in the imperative programming language: variable, condition with if and else, loops with while. If this is your first exposure to Python, don't worry about being able to write a similar program yourself. Learning programming requires practice, and although you are now understand and explain this program, practice the indi- practice is indispensable to write something familiar. We strongly encourage you to compare the code in this room with that of a JavaScript simple code demo room coming soon. This will give you a good perspective of how different modern program languages are designed and written. In the next room, JavaScript simple demo room, we will dive into an example program written using a JavaScript language. JavaScript written in your web browser to make website more interactive. Moreover, it is powering an increasingly large number of web applications thanks to Node.js. You can explore it in the next room. Wow. Uh, there is two. Let's do that today itself. Wait a sec. Mm, where to how to go with the path? Oh, then there is attack and defense. All right, let's go. Uh, hello. Hello guys. After completing Python simple demo, we have here this room JavaScript simple demo. This is from software basics module from pre-security path. It is a premium room. You need a subscription to do it. Explore what a basic JavaScript program looks like. Let's go. The purpose of this room is to give you an idea about one popular programming language, JavaScript. It is most certain that you have come across the name JavaScript. However, throughout this room, we assume that you have never studied or written program in this language. JavaScript is used in the most of the web pages that you visit on the day-to-day basics. Consequently, when you think of JavaScript engines, web browser come to mind. In fact, the JavaScript was initially developed to run on a client machine, in particular within the web browser. However, this has changed with the release of Node.js, which enables developers to build web applications with JavaScript. Consequently, as Node.js spread, JavaScript is no longer just a client-side programming language, but also a server-side one. In this room, we will create a guess the number game. Our plan will as follows. The computer secretly picks a number between 1 to 20. The user keep guessing until they get it right. The computer tells the user whether their guess is too low or too high. An example session running the program is shown below. I am thinking of number between 1 to 20. Take a guess. Too high. It is same that we learned in the previous. We will try to follow an approach similar to the one we followed in the Python simple demo room, and we choose the same idea to implement. The reason for this is to allow you to explore the main language difference from the same program idea. Learning objective. Learn about JavaScript variable, understand how conditional statement is used, see the iteration loop in action. We did all that. Let's go. Variables. Mm. You can follow along by starting the VM by clicking the Start Machine button shown above. Visual Studio Code should open automatically as shown in the screenshot below. Setting the stage. Before starting, we should point out that JavaScript file can be executed in various ways. One way is to use your web browser and another way is to use Node.js. However, for our purpose, the easiest way to get started is by using Node.js. It is easy to download for your system and run your JavaScript file from the command line. If you are curious about running JavaScript in your web browser, it is pretty simple. In your web browser, access the web developer tool. For example, I need to press F12 in Firefox to open the console, where I can run JavaScript code. A screenshot of the web browser running JavaScript code is shown below. Note that this room, wait a second. Uh, Note that in this room, we will test our JavaScript code exclusively. Node.js. The process can be run by typing node demo.js at the command line, where demo.js is the name of the JavaScript file, creating a variable. Going back to our game, we need to start by declaring the variable. We think a variable as a space in the memory that stores a value and allows us to change its value later. For example, we want to keep track of a number of tries attempts a user has made as well as the user's guess. We can do this by declaring these two variables. Let price, let guess. The let indicates that we are declaring variable. When the user start, they have not made any attempts, so tries is set to 0. Moreover, we initialize guess to a value that cannot accidentally be the secret number that the user is trying to guess. On a side note, secret is constant and will be covered in the next subsection. Remember that a secret number is between 1 to 20. Creating a constant. We use let to declare variable whose value can change throughout the program. However, we use constants to declare constant, SONST, whose value cannot change throughout the program. The secret holds the number that we will try to find by guessing, and it should not change as already mentioned. To declare a constant, we use the keyword constant. For example, const secret is equal to 12. To ensure that a secret gets a new random value each time we run the program, we need to use JavaScript math.random method. Constant secret is equal to math.floor math random star 20 plus 1. There is a although although the details of this expression are not the key purpose of this room, we will share a brief breakdown of the for the curious readers. Math.random gives a random decimal between 0 inclusive and 1 not including 1. Example 0.372. What the hell? I didn't get it. Star 20 structures that range from 0 to almost 20. Example 7.4. Oh, it will give point also. All right. Math flow. That is why I am thinking, why is there a math floor removes the decimal. Then why it's this? There is this number. Removes the decimal by rounding down. Example. So math floor is for this one, but math random, it will give the random number, but it will have decimal of this star 20. It will stress us to the 20, and math floor will remove the decimal by will round up. If it is 66, it will go to 8. Plus 1 shift the range from 0 to 19 to 0 to 20. As a as a result, secrets end up being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. Displaying output. Once the secret number is picked, the program should inform the user that the step is complete. To display the secret and to display on the screen, console log can be used in the example expression below. The string included between the double quote we will display on the screen. Console, I am thinking of a number between. What word is used to declare the variable? Variable को declare करने के what was the number we used to declare variable, that is let. Remember that is important. What word is used to declare the constant, that is constant. Constant. What is the method that we call to display text on the screen, that is console log. Console console log bracket. La 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 la. What the hell am I doing in this life? Let's see. Before starting, please note that you can download the attached zip file. It includes all the versions of program that are present on the target VM. This search will allow you to review the project's evolution, compare implementation, or test each version independently to your local machine. Having all iteration in one package should make your work more efficient. In the previous task, we set our variable and constant. Moreover, we picked a random secret number for the user to guess. Now we need to prompt the user to take a guess and enter a number. In the first line, we wait for the user to input a value and save it in the text. In the second line, we place the text as an integer of base 10 using place int text 10, that is place int. The present method takes the user input and converts it from text into integer value. Wait a sec. Uh, Well, let's go. I don't know if my voice is clear or not. Let's go. Context awaits a request. Take a guess. Guess present in optional note. Let's see. What the hell? This much big note. Let's go. We did it. The await instruction pause the system until the user responds. Obviously, Node.js's default behavior is not to wait for the user to enter the value. Remember that the Node.js is built as a runtime environment for the web application, not to run such as a command line JavaScript program. Consequently, we need to use libraries to override the default behavior and force Node.js to wait for the user. The following line achieve this. Import as readline from node readline promises. Import string as input as dot as output from node process. Constant R1 readline create interface. I don't know. Let's see. Here it is. Explanation. The first line borrows import the readline module so that the program can ask question and wait for typed answers. The promises part means it can pause neatly until the user responds. The second line imports two module std, stdin short for standard input, usually the keyboard, and the std output is short for standard output, usually the screen. Moreover, it renames them to input and output respectively. The third line set up the conversation channel using the microphone from the from line 1 and fires from fine line 2. Why is it so complicated to get command line input? Because we are using Node.js to test our JavaScript program. We do not need to keep the server we do not need to keep the server busy waiting for the user input. Deviating from the expected default requires us to add these extra library imports. Clean execution. To read user input, we add to create an interface. We link to a microphone before the program finishes. We need to close this interface. You would also switch off your microphone after a Q&A session. To close the interface, we use R1 close. As a result, our code will declare and initialize the R1 short for readline. Use it to get text text input from the user and close. These three steps are shown below. Readline create interface input output. Try constant text await readline question. Take a guess. Uh, Finally, all right. The try block creates the try block creates a safe environment so that if something goes wrong, the program won't crash. Think of it as a trying to run a set of statement, or if something happens, handle it gracefully and finally clean up. Let's summarize what are we doing. We are importing readline module with the promises part indicating that the script will handle the waiting without freezing everything. Then we imported the output and input as input and output. What the hell? That was reading very hard. Using these imported modules, we create the readline constant with the name R1. The program makes it guess using math random and save it that as a secret, a constant. We declare two variables, tries and guess. We displayed on the screen that a number between 1 to 20 has been selected. The user's response is considered a guess and will be saved in text, a, a constant. The user response is converted to a number using phrase int. The number of tries increased by 1. Finally, we clean up and close the readline interface R1 that we created earlier, putting it all together. This is the first draft we have built so far, listed below, and is also available on the system guest view on JS. It can be found in what's missing. The most glaring missing component is that the user receives no feedback even if they get the correct answer. That gets this compliment implemented in the next task. What's the method used to convert user input into a number? That is, mm, where we change it. This one, paste, present it. Let's see. Huh? It is Python. We need JavaScript. Sorry about that. Uh, is that the first one? Yes, it is. Let's see. How to run it, man? Uh, if I remember correctly, how to run that? Wait a sec. Sorry about that. Uh, run GUESS. We I don't know, man, how to run it. This is not like Python. How do we try this? Let's see. Wait a sec. We will do it in this. Let's go. Uh, Wait a sec. Take a screenshot. Uh, how do I run that? How the hell? How do I that? Mm, oh, we use Node. Okay, sorry about that. Let's go. Let's see. Let's see. Let's see. Paste. Let's see. What? Yeah, we used to use Node. All right, guess the number. We would use 10. Solid 10, huh? Oh, that is the first model. Let's see. In this, we will see. Uh, Wait a sec. We will need to go here and uh, We are using 2. Let's see. Guess the number. 10. Triangle. Too high. Oh, it's direct squid. Alright, alright. Let's see. Uh, let's see. Third. Mm, guess the number 10. 10 is too low. Let's go with 15. Too low. Let's go with 19. Too high. Let's go with 17. Too low. Let's go with 18. 18 is the answer. It's very good. That script is running properly. Let's see. So far, you are playing the guess the number game, and the current program has no way to provide the feedback on your choice. It asks you to make a guess and is both silent. Let's make things more engaging and advance our program so it can evaluate user input and provide feedback. We will follow the following logic steps. If it is outside the valid range, not between 1 to 20, we will tell the user that their number is out of range. If it is less than the secret the number, we inform the user it is too low. If it is greater than secret, we inform the user that it's too high. If it is not greater than that and not less than the secret number, it means that it is equal to secret number and user has finally guessed it. From the above comparison, you can see that if the first condition holds, there is no point in checking the second condition. Moreover, if the second condition holds, it is less than secret, there is no point in checking the third condition because the conditions are mutually exclusive. We can make use of else. We will present the condition using JavaScript and discuss them afterwards. Is same as that plus elif. Instead of elif we use else if. The above is if else if and else statement will execute as follow. If guess uh, it is lesser than, right, lesser than 1, guess is greater than 20, the guess is it is in the written form. If the guess is less than 1 or guess is greater than 20, then use console log to tell the user that the number is out of range. Note that double slash straight slash present or in the JavaScript, all right. The else means that if the previous condition is not true, run the statement. If guess lesser than secret, will evaluate whether the guess is less than the secret. If this is the case, we will use console log to display too low. Similar, Similarly, the else will ensure that this statement won't run unless the if as evaluated to false, assuming that the last if condition evaluated to false. We will assume its condition. In that case, the guess is greater than secret, the console log display to I. Finally, we see an else setting by itself. This else means that if all previous if conditions are evaluated false, the enclosed statement will execute as we established earlier. We, if all previous conditions are evaluated to false, it means that the user guessed the number. Put it all together. Our draft can be updated to include the condition we covered in this task. The previous draft will be expanded to provide the user feedback on their guesses. The updated program we have constructed so far listed below also available. Import, we will add the read line. Import, we will add input output. Uh, Constant array, we created this and we will use try, it will safe environment, something like that. We'll use it to, sorry about that. No, we use it to this, what is this called, variables. Sorry about that, which one was that? Uh, let's go from here. Console log is showing the output. It is like print, right? This is guess. It is in that we had int dot is here is per se plus. This is same as that. Let's go. This is clean, clear up. It is clean, binary clean up, something like that. Let's quickly review what the code does. If the it picks a random secret number between 1 to 20, it keeps track of the user's guess and the number of tries. Then it asks the user to take a guess. The user's guess is received as text and converted to the number and saved in the guess. We compare guess with the secret and give feedback to the user about their attempt. Make sure that you have a good understanding of the script so far. You are not expected to write it yourself, however, you should be able to explain it by the looking at it what is missing. This code run once, giving user a single chance. This situation is shown in the interaction below. Uh, I am thinking of number 1 to 20. Uh, Take a guess. Roll or try again. Obviously, that's not fun game. If the user gets only one chance, we need to give the user more chances until they can make the correct guess. In this task, we will get our script to provide the user with the many chances to make the game more fun. The secret is then what will our program display on the screen if the user makes a guess of 15. That is too high, try again. The secret is then what will our program display on the screen if the user make a guess of 35. This one is out of range. The script we have so far efficiently provide feedback on the user's guess. However, it does not give them a second chance. In this task, we will make the necessary chances so it takes it keep prompting the user to new guess until they figure it out. One way to achieve this is to keep promoting the user to make new guesses as long as their guess is wrong. While their guess is not equal to secret, that's quite easy to express in JavaScript. While guess not equal to secret, the apostrophe is equal to means not equal to. I don't know what that sign mean. This mean. Alright, forget it. This is called while loop and it's done show below, same as the before. If you don't add this, it will see. Let me show you. As you see, we when we tried, it did not go on like again and again option, right? It will only did once. But when we tried on this, it had that. Let's see, wait a sec, where it is. Does not have it. Then how come? We got five tries. It does not have a while loop. Oh, here it is while loop. This 24th line. Let's go with 24. Oh, it is here. See, in this it is not there. Oh, it is correct. It is working, but this one not have. As you can see, does not have that. Fun, 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 fun. The next part is to decide what to include in the main body of this while loop based on the program logic we have built so far. We should repeat the following. Prompt the user to take a guess, convert the user input to the number and save it in the guess. Increase the number of tries by one. Check guess with respect to lower and upper limits. If it's within the limit, compare it to the secret number. Display the feedback to the user about their choice. And we will repeat this if the user didn't make the correct guess. The JavaScript code with the while loop field is shown below. Uh, this is a while loop and it is everything added. Uh, you can test it on the system by running your new pick of secret number as we did that. It should be noted that the node chess4 on the VM and in the zip file attached to task 3 further improves this program. You are encouraged to take a look at however it is not critical to the introductory room. Let's see. They are saying we need to see this. Let's see. What is this defender summary? Let's forget it. Let's see. This is same. Oh, they added this like right in this. They added this here. This one math. But in this, they changed it to this max number, min number. See in this, you just they in that they are just to did it everything here, but it is on new. This is the user didn't type the digits. We avoid crashing and ask again. True only if all characters are digit. Oh, they added like this. Oh my god, this is very improved. All right, you can see that. And what is the name of the loop that we used in this task? That is while HILE. What is the name of the variable that is incremented by one when the user makes a new guess? That is twice real. Uh, how is not equal is written in JavaScript, that is uh, equal to. Why it is loading so much? Yes, it is correct. Conclusion. In this room, we covered three key pillars in the imperative programming language: variable, condition with if and else, loops with while. If this is your first exposure to JavaScript, don't worry about being able to write similar program yourself. Learning programming language requires practice, and although you can now understand and explain this program, practice is indispensable to write something similar. We strongly encourage you to compare the code in the room with the Python. This will give you a good perspective of how different modern programming languages are designed and written. In the next room, database SQL basics, we will explore SQL. Although SQL is not programming language, it is commonly used to query relational database system. For now, think of it as a relational database as a large set of related tables. I will come back in a minute. Hello guys, we are gonna continue pre-security path software basic module. Today is database SQL basic. Learn the basics of database and SQL by writing simple queries to retrieve and manage data. How can cafe keep track of every order and still quickly answer questions about them later? In the computer fundamentals module, we have seen how computers can process information while running. But what happens when the computer is turned off? Where does the information go? In this room, we will be helping small business make sense of its data. As the company grow, keeping track of the information using simple files becomes slow and confusing. Database solves this program by storing information in the structured way that is easy to search and manage. Learning objective. Understand what data is and why it matters. Explain what is database in what explain what is database is and why it is used. Understand what SQL is and what it is used for. Identify table, rows and columns. Write simple SQL queries to retrieve information. I am ready to dive deep into database. Let's go. In the cafe database table, what does one row represent? Price. This is row, this is column, all right. In this table, each column represents one type of information such as name or price. Each row represents a complete record and the table contains all the records. Imagine a small cafe. At first, the cafe owner writes each order in paper, notebook to track order and payments. In each order includes drink name, price, and the time of the order. This works fine when cafe is small. However, after many days, notebook become full. Finding answer to the question like how many coffees were sold today or what was the cheapest drink sold this morning becomes slow and difficult. The owner has to reach to many page and count orders manually. This is where computers and database become useful. What is database? Think database as a place where a computer stores information in the original way. You think of a database as a digital notebook that never runs out of page. Unlike a paper notebook, a database allows the computer to search, count, and sort information very quickly. Even if the cafe has thousands of orders, database can still answer the question in seconds. Inside the database, information is stored in tables, rows, and columns. A table resembles a spreadsheet where information is organized neatly into rows and columns. Columns are titles at the top of the table. They describe the type of information stored. Rows go across the table. Each row contains one complete set of information. For the cafe example, column might be order number, drink price, and time. Each row is one cafe order. This means one column stores one type of information such as prices. One row stores all the information about the single order. If the cafe sells 10 drinks in one day, the table will contain 10 rows. If one more customer places an order, one more row is added to the table. If an order is removed, only that row disappears. The rest of the table stays the same. Asking question with SQL. SQL is a language used to ask question of database. Instead of reading the table row by row, SQL lets the computer do the work for us. For example, cafe owner might ask, show me all orders, show me only cafe orders, show me the cheapest drink. These questions are called queries. A query does not change the data, it only displays the requested information from the table. In the next task, you will learn the simple SQL query to ask these questions yourself. Inside the database, what is the term for spreadsheet that the stores that is table? Table. We add this in 12th man. Select star from table. Select star from orders. We add that. La 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 la. Uh, In this task, you will use a browser-based method, browser-based database client. Nothing here can break. If you make a mistake, you can click reset data and try again. At the top of the page, you can see the two tables and their columns. ID, drink, price, time. Menu, drink and price. Your goal is to precise writing queries using the 4 score SQL part. Select from where and order by. Step 1. View everything in a table. Select star from. We start with the most basic query. When we use select star, the star symbol means all columns. The word from tells the table which table to use. This query, select star from orders. Click run query. You should see the order. You should see that. All right. Step 2. Show only specific column. Select drink price from order. Uh, Sometimes we do need every column. We can choose specific columns by listing select select drink price from orders. This will display the only drink and price columns. See, filter result where the where keyword filters row. It keeps only rows that matches the condition. Select star from orders where drink is equal to coffee. It will show only coffee. And if you are not sure which drink name exists, run select star from menu. Sort result order by. The order by keyword sort the result by a column. By default, results are sorted in ascending order, lowest to highest. Price sorting orders by the price. Select star from orders, order by price. Select star from orders, order by okay. It will give like order, like increasing or decreasing order. Which order? Uh, by default, the results are sorted in ascending. It will give in ascending. All right. Uh, to sort in the reverse order, add disk. Select star from orders, order by price disk. Right. Combine the filter plus sorting. Select star from where drink is equal to coffee, order by the price. All right. When you show all orders, how many rows were written? All right. Uh, Select star from orders. Let's see. 50 rows. 50. When you sorted orders by price from cheapest to most expensive, which drink appeared first? Uh, Cheapest to that is select star from this one, not select star from order. This one. Copy. This one is important. If you miss this, you have to use it. If you do not have it, it will not work. Uh, paste and run the query. There you have it. It is T. Answer is T. EEA. When you sorted the menu by price from most expensive to cheapest, which string appeared first? In that case, you will add DESC, right? Sorry about that. DESC. That was right. DESC. Let's see. Latte. Latte. Uh, we did this. We did this. Let's do from start. We did that. It is very easy. Uh, we had it for 5 mark question. We did that and we got the marks. What did it is done is select ring price and it will only show 2 column price and ring, all right. Then there is this one. Let's see what does it do. Uh, Select star from orders where drink is equal to coffee. It will only show orders where drink is coffee. Drink is coffee. See, eh? Select. All right, I didn't run that. Sorry about that. Let's see. It will show the menu. Let's see. Let's see. Yes, espresso tea, coffee, hot chocolate, latte. Let's see how to get hot chocolate. Let's see. To get the hot chocolate, where it is. Select star from orders where here. Copy. Uh, uh, Hot chocolate. Let's see. Uh, wow. Very. You can do some chat GPT and you can get it. If you want to learn it, you can learn it also. And conclusion. In this room, we learned how computers store information in the database and how SQL is used to ask clear question about the information. Using a cafe example, we saw how tables organize orders into rows and columns and how simple SQL command can show, filter, sort, and add data. Skills learned, understanding what database is, knowing what tables, rows, and columns are, asking simple question using SQL, reading result returned by the table. SQL queries learned in this room. Select, choose what data to display from, choose where the data comes from, where filter records based on the condition, order by sort. Question to think about. What could happen if someone were allowed to change or remove cafe order without permission? Great work. Finishing this room, you are building a solid foundation to keep. Question that what could happen if someone were to allow to change or remove cafe's order without permission? It will give lots of problem, right? What could happen if someone were to allow to change or remove cafe? There is two condition. If they added the order, then they have to pay extra tax. That is not happened. The sales did not happen, but they added. If they added less, and they could go to jail for tax invasion. A successful computer just can write basic SQL queries. Success. Yeah, baby. Oh my God, this guy is in fifth position, but he's working hard. He's from India. Wow. Weekly leagues. I did not want to come here. Leaderboard switch. Do you know how to get in this leaderboard? Just by the scores. They scored this much. Uh, let's see his badges. What the heck is room? Let's see his badges. Oh my God. The return of Etty. He did that. This part. Let's see super hard. That is common. Uh, Windows privilege escalation. Is there a module? If there is, I need to do that. Uh, oh, let's see. Windows privilege module. Windows. Uh, is this one breaking Windows? Yeah. Mm, modules. Do Windows privilege. I have this wrong. I completed that. Do I have this patch? Yeah, yeah. Finally, I am with the 1%. Oh my God. Finally, guys, I am the 1%. I like it. Oh my God. Finally, guys, I am in top 1%. Let's see my badges. World Wide Web, 7 days stay, flat Linux. It was very security awareness, very high. I didn't do something very impressive, right? Very common thing. And let's see, penetration to completing the penetration so series. This is impressive, I guess. Uh, Advent of Cyber 3, 1%. Wow, I have it. Advent of Cyber 4. This one had highest people, right? This one is 1%. This one had very much. Alright. I do not have that. Uh, Windy Windows window. What is this? I completed 50%. I should do that sometime because let's see. Oh, completed. I completed so many. Yeah, right. Let's see, completed one in progress. Software as a this module will introduce you to software development life cycle and what is 6%? Seven. Hey, I did this. Diamond model. Well, I guess source and privilege escalation. Remember that in progress. Not only and more. What is SMB? Server message block protocol is a client server communication protocol used for sharing access of access to file, printers, and serial ports. Started before we begin. Enumeration is a process of gathering information on the target in order to find the information. Enum4 Linux is a tool used to enumerate assembly shares on both Linux and the system. It's basically a wrapper around the tools. In the Samba package, it makes it easy to extract the information from the target penetrating to assembly. It's already installed on the Atanga, where if you need to install on your own machine, you can use official GitHub. That's it for today, guys. Let's end it. See you 2 hours of stream. I guess that is more.